I will give you a brief introduction of the functionalities our H1 play reader has. It's a very powerful instrument which can essentially do pretty much a lot of different kinds of detections. Yeah, the one we have is it's pretty much the same as the one described on the website, but it's I think the just the outside is gray instead of white. Um, okay, yeah, this is Biotek website. We can just scroll it through. Um, in terms of applications, you can use this to read cells. You can do kinetic measurements, different detection modes. Okay, I think one of the key features for Biotek is it has both the so-called monochromator based detection and filter based detection. A lot of instruments actually you see in the market they do either monochromator or filters. Both detection modes has its own pros and cons, right? Monochromator, the good thing is it's you can choose whatever wavelengths you want, but the downside is that you have a fixed bandwidth here. For filters, it's not as versatile as a monochromator, but it can give you, essentially any kind of bandwidth you need, and the signal sensitivity is generally better. Um, yes, for our play radar, we have all these different accessories for the play radar. We have this CO2 um, you know, gas controller, yeah, CO2 gas controller for live cell continuous monitoring, and also we have this dispenser, right? So you can dispense reagent directly into the microplate. In terms of detection, it can do absorbance, fluorescence based on intensity. It can also measure luminescence, and with this um, you know this is a reagent, what this thing called, but titration thing, right? So you can do this so-called flash luminescence. Basically, you can synchronize the addition of your reagent with the readout. But if you don't have this thing, that wouldn't be possible, right? So you cannot put your plate in there within like less than 1 second. Um, it can also do this so-called filter luminescence. Yeah, in this case, you need to use filters based use filters to filter this luminescence different for different wavelengths. That's generally useful when you have a few different kinds of luciferases and they have different kinds of emission wavelengths. And our plate reader can also do this so-called fluorescence polarization. That's a filter-based application, and also it can do this time-resolved fluorescence. Right? We'll talk about that in detail later. And also you can do this so-called time-resolved fluorescence energy transfer. Right? Time-resolved TR-FRET. So for these, you can actually for TR fluorescence and TR FRET, you could use monochromator, but it's highly recommended to use filters. I think for TR fluorescence fluorometer, monochromator would be okay, but for TR FRET, because of the narrow bandwidth we want to achieve, and also for the excitation, but for emission part, we want to have wider um, bandwidth. So um, filters are highly recommended. Okay. We do not have this function, so-called variable bandwidth for sensitivity and specificity. The newer version of H1, they can tweak the bandwidth for monochromator. But frankly, this function, it sounds pretty cool, but the thing is because of the very complex, this so-called quad monochromator optics, actually dramatically reduces the light intensity. So overall, although you get a broader bandpath, but your sensitivity may not be significantly increased or say proportionally increased because of the extra optics you have to use. Okay, so we don't have that. Um, and this function is called automated Z focus. This is extremely important. Okay, so I want everyone to pay attention to. So this one, what it means, it's basically, when you collect the signal, when you shine light in the solution, it will have a focus, right, in the solution. And so, for example, like here, if you have a 300 microliter solution, yes, that's okay, right? So you can focus here or here, it doesn't really matter. But you have only 100 microliter. If you focus here, that's basically you are focusing in the air, and that will dramatically affect your readout, right? So with automated Z focus, that means you have less solution. Instrument will know, and they will adjust the Z value. But so this thing is, the thing is, instrument will not know automatically. So what you have to do is you need to do a so-called Z optimization process, which will be shown later. And yeah, this one is H1 offers the extended dynamic range, yeah, to the 10 to the 7th. And we have a CO2 incubator for the plate reader. We cannot control the O2 using this gas controller, but actually we do have a dual gas controller, CO2 O2, on the imaging reader side. So if you really need to use the O2, you used to control need to control the O2 content, we can swap the gas controller. Yeah, this is called Syringe Injector, right? We have this device on the plate reader. So essentially you can add reagent. If you are doing a steady state experiment, this is not very useful because of the depth volume is huge. It has about 1.1 mil depth volume. So only if your reagent is pretty cheap, you can do that. If you have very expensive reagent, this thing is not very useful. This is mostly useful when you need to do, like kinetic studies, and especially time zero is very crucial to you. Otherwise, you can just manually add it outside and then put a plate in the plate reader. So there's another very useful device we have. It's called the micro volume analysis with Take-3 plate. So this Take-3 plate is shown here. So it's a pretty cool technology. It's kind of like NanoJob, but NanoJob can just do one sample each time. So this one, the way it works is, the black area is a Teflon, right? So then you can pipette 2 microliter of your solution onto this plate. You can even use multi-channel pipette, right? So we have this Take-3. So essentially, you can have this like many samples here, right? So the way it works is that once you pipette 2 microliter solution here, and you fold it back, you form a sandwich basically. And so in the plate reader setting, you should choose the Take-3. So using this device, you can measure, you can essentially do all the different sample modes you want to use here, right? So essentially, this is just like a microtiter plate, but with very small volume, like 2 microliter. So that's actually pretty powerful when you have very limited samples. Yeah, for example, like you have proteins or nucleic acids, so that would be very useful.